All right, welcome to The Explainer. Today, we're going to talk about a technology that basically sounds like science fiction. I want you to get ready to flip the script on everything you think you know about data, because we're diving into a way to hold a file, not by saving it, but by saving a tiny, tiny recipe that lets you perfectly recreate it on demand with nothing but a beam of light.
So to really wrap your head around this, I need you to just forget everything you know about hard drives and SSDs, just for a minute. Imagine a world where that movie file or your favorite song doesn't actually exist in any physical form. It's just not there until the exact moment you hit play. And I'm not talking about some clever compression trick. I mean, it's generated from pure nothingness, from scratch, every single time. And this right here shows you the huge shift in thinking. On one side, you've got traditional storage. You save the whole thing, right? A static, physical object made of billions and billions of bits. But on the other side, you just save a tiny recipe. Data stops being a thing you have to store, and it becomes a dynamic, predictable event. It's something you literally summon on command.
So you're probably asking, how on earth is that even possible? Well, the secret to this whole crazy idea is actually hiding in a classic, pretty simple physics experiment. It's all about how light can create these perfectly predictable patterns that we can then, well, read like a book. It all comes down to something called an interference pattern. You know, when light waves bump into each other, they can either team up and get brighter, or they can cancel each other out, creating a dark spot. But here is the most important part. This isn't random. Not at all. It's pure physics. It's a deterministic outcome, which is a fancy way of saying it happens the exact same way every single time you do it. Okay, so you've got these cool-looking stripes of light. Now what? How do you get from that to actual digital data? Well, the process is surprisingly simple. You shine the laser, you get that predictable pattern of bright and dark spots. Then you just put some tiny detectors there, and their job is dead simple. If they see a bright spot, they shout 1. If they see a dark spot, they shout 0. And bam, just like that, you are literally reading information out of thin air.
Right, so a few ones and zeros are neat, but that's not exactly going to stream a 4K movie, is it? To go from a simple line of bits to something as complex as a whole film, you have to scale this idea up. I mean, way, way up. And to do that, you need this incredible machine. You can basically think of it as a kaleidoscope computer.
This machine is called the Rig, and really, it's like the most advanced, most complex kaleidoscope you could ever possibly imagine. It takes that basic physics principle of light interference and gives us what is essentially godlike control over it. It's got a laser, a prism full of mirrors to bounce the light around like crazy, and then its secret sauce, a programmable shimmer lattice that can shape that light with just unbelievable precision. This quote just nails it. It says it's like thousands, millions of experiments all happening at once in this beautiful, coordinated, shimmering dance. And that's exactly right. The Rig isn't just one little experiment. It's like a whole forest of them all nested inside each other, with light bouncing around in this insane mirrored labyrinth. That hyper-complexity, that's the whole point. That's where the magic comes from.
So the Rig can create these mind-bogglingly complex patterns of light. Amazing. But here's where it goes from cool tech to, wait, what? The real breakthrough, the part that changes everything, is how it remembers which specific pattern to make for any given file. This right here, this is the big aha moment.
Okay, so think about a movie you might have on your computer. Let's say it's 10 gigabytes. In our world, that means you need 10 gigabytes of physical space, on a hard drive, on an SSD, whatever, to hold every single one of those bits, period. That's just how it works. But with the Rig, you don't store that 10 gigabyte movie at all. Instead, you store this, a tiny little instruction file called a manifest, and it might only be 30 kilobytes. I mean, just think about that for a second. The difference in scale isn't just big, it's absolutely astronomical. It's a completely different universe of efficiency. So what the heck is in that tiny little file? Is it some kind of super compressed version of the movie? Nope, not even close. Look at this. It's just a set of instructions. It's the blueprint for the hardware, the exact settings for the shimmer lattice, the size of the file it's supposed to make, and a digital fingerprint to make sure you got the right thing. But look at what's not there. Not one pixel, not one soundbite, 0 actual data, just the recipe. So this is the crucial takeaway. Reading a file is the wrong word now. It's a process of regeneration. You just feed that tiny manifest into the Rig, the
The hardware configures itself, you flip the switch on the laser, and the light itself, just by following the fundamental laws of physics, does this ridiculously massive calculation for you, creating the shimmering pattern that is the file. The universe does all the heavy lifting. Now, okay, this is where things get really, really deep. Because a technology like this doesn't just change hard drives. It forces us to step back and ask a much more profound question about what information even is in the first place. Just let that one sink in for a second. You're storing them in possibility space. What does that mean? It means the data doesn't exist in a physical place anymore. It exists as a potential configuration of the universe. The information isn't a thing. It's just one specific point in a vast, almost infinite landscape of possible light patterns. And that manifest file? It's just the map coordinates to find that one specific point. And that changes our entire role in the world of information. For all of human history, we've been building things, painstakingly stacking bits one by one like bricks. But with this, we stop being builders and we become explorers. The information, in a way, already exists out there as a potential. Our job is just to find the right map, the right recipe, to go and discover it. It's kind of like this. Imagine you're standing in front of a giant ocean. The old way of doing things is like having to freeze all the water and painstakingly carve a ship out of ice. But in this new world, the ship already exists within the ocean's potential. You don't have to build it. You just have to find the perfect whistle, the right song that causes the water to rise up and take the shape of the ship for you. Okay, so let's bring this all home. We've seen how a massive 10 gigabyte file can be literally conjured into existence from a tiny 30 kilobyte recipe. But you have to realize this idea is so much bigger than just movies or music. And that leaves us with this one final, truly mind-bending question. If any file, any database, is just one set of coordinates waiting to be found in that vast possibility space, what else is out there? What other incredibly complex, beautiful, or useful systems are just floating out there in the shimmer, waiting for us to discover the right manifest, the right strange song to bring them into the light?